All right, let's dive in. We're going to move way beyond the world of digital art and bored apes today to talk about something much bigger, the real high-stakes future of NFTs. We're talking about tokenizing serious, real-world business assets, and we're going to break down the incredible tech that actually makes this possible.
So, let's just start with a huge question to get our heads around this. How in the world do you put a multi-million-dollar jet engine with all of its blueprints, its maintenance logs, its financial records, onto a blockchain? I mean, it's obviously not as simple as right-clicking and saving a JPEG. This is exactly the kind of massive challenge that enterprise blockchain was built to solve.
And that really brings us to the heart of it. While digital art and collectibles got all the headlines, the true revolution here is applying this token technology to complex, high-value, real-world stuff. This is where the game completely changes for huge industries like finance, manufacturing, and global supply chains.
See, the core challenge for any big business isn't just minting a token. That's the easy part. The real problem, the hard part, is creating an absolutely unbreakable link between that token and all the massive, critical data that gives the asset its value. We're talking gigabytes of blueprints, contracts, and logs that have to stay secure and accessible forever.
This leads us right into the central technical hurdle that's honestly held enterprise blockchain back for years. Let's call it the billion-dollar data problem.
And here's the name for it, the asset decoupling problem. It's pretty simple, really. A blockchain is a hyper-secure ledger for proving who owns what. It's absolutely phenomenal at that. But it is a terrible, inefficient hard drive. Trying to store something like a detailed 3D model directly on the chain would be unbelievably slow and could literally cost millions of dollars in fees. It's a non-starter.
And this slide just lays out the trade-offs perfectly. On-chain storage is secure, sure, but it's crazy expensive and it slows everything down. Off-chain storage, on the other hand, is fast, scalable, and cost-effective. So the real solution has to be about getting the absolute best of both worlds, linking that fast, scalable off-chain data to an on-chain token with all the security and permanence you expect from a blockchain.
So how do you do that? Well, the answer is a really elegant three-layer solution. We're about to see how three totally distinct technologies come together to solve this problem, creating a system that's secure, scalable, and actually built for business.
Probably the easiest way to understand this whole architecture is with a simple analogy. Just imagine a super high-security record system that has three parts: an indestructible vault where the ownership deeds are kept, a permanent library where all the actual documents are archived, and a really smart, expert librarian who manages the connection between the two.
Okay, first up, we have the vault. In our system, this is Hyperledger Besu. It's an enterprise-grade private blockchain from the Linux Foundation's open-source Hyperledger project. Its only job is to be the ultimate source of truth for ownership. It securely stores the NFT, which acts as the unforgeable deed to the asset. It's built from the ground up for privacy, performance, and finality. And this chart really shows you why Besu is the perfect choice for the vault. Unlike public Ethereum, where a transaction might, in theory, be reversed, Besu gives you immediate, deterministic finality. That means when a transaction is done, it is done. It's also way, way faster. And this is huge for business, you can configure the transaction fees, what they call gas fees, to be zero. That removes a massive operational cost and headache.
Okay, so that's the vault. Now, where do we actually put all the files? That brings us to our library. For this, we use IPFS, the Interplanetary File System. Think of this as a permanent, global, decentralized archive. This is where the actual asset files, the blueprints, the financial documents, the 3D models are going to live.
Now here's the crucial part, the real magic of IPFS. A normal web link points to a location. If the file at that location moves or gets changed, the link breaks. We've all seen that, right? It's called link rot. IPFS is different. It uses what's called content addressing. The link is a unique cryptographic fingerprint of the file itself. So if even one single byte of that file changes, the address changes. This is what guarantees that your NFT will always point to the exact correct version of the asset data. It is a permanent, unbreakable link.
All right, so we've got our vault and our library. Now we need our expert librarian to make them work together. This is where Hyperledger FireFly comes in. It's this powerful middleware layer that orchestrates absolutely everything. FireFly is the brains of the operation. It manages all the complex API calls, the transaction submissions, and the data syncing between the vault and the library. It's the secret sauce that makes the whole system work seamlessly.
Okay, so we've got our vault, our library, and our librarian. Now let's walk through exactly how these three layers work together in practice to take a real-world asset and mint it as a secure, enterprise-grade token.
So it's a four-step process. Step 1, the asset file, your 3D model let's say, gets uploaded to the IPFS library. That spits out a unique content ID, or CID. Step 2, you create a little metadata file, like a library card, that describes the asset and includes that CID. Step 3, that metadata file also gets uploaded to IPFS and it gets its own unique CID. And finally, Step 4, our librarian, FireFly, tells the vault, Besu, to mint an NFT, the deed, that points permanently to the metadata's address. And that's it. The link is complete and it is unbreakable.
Now, once you know how the data is linked, there's a really important business decision you have to make about where it's stored. As this slide shows, you can choose a private IPFS network, basically a walled garden just for your sensitive internal documents, or you can connect to the public IPFS network, creating a bridge for assets that need to be seen by the whole world, like collectibles or brand marketing materials.
So what does this all mean when you put it all together? Well, when you combine these pieces, you get an architecture that finally makes this tokenized future a practical reality for businesses today. Let's just quickly recap why this is such a game changer.
This whole setup just changes everything for a business. You get the certainty of instant, irreversible transactions. You get the efficiency of having zero gas fees, which gets rid of huge operational costs. You get the scalability to handle an asset of literally any size. You get enterprise-grade security. And maybe most importantly, you get practicality. That librarian, FireFly, handles all the complex plumbing, which cuts development time for these projects from months or even years down to just a few weeks.
And that brings us to our final thought. If any asset, physical or digital, from a jet engine to a financial contract to a piece of intellectual property, can be securely owned, fractionalized, and traded this way, what will we own tomorrow? The possibilities are just absolutely staggering. Thanks for digging into this with me.